Good morning, children. Sairam. Children, I hope you all have understood the two types of cells that we have studied in the chapter. That is the electrochemical cell and the electrolytic cell. Electrochemical is that which converts the chemical energy of the spontaneous chemical reaction into electrical energy, and electrolytic cell was that which converts the electrical energy into chemical energy. That is, electrical energy is used to drive the non-spontaneous chemical reaction. Now children, today we'll be discussing about some of the commercial cells or batteries. That means we'll be discussing about the cells or batteries that we are using in our day-to-day life. Now children, there are generally two types of cells. These are the primary cells or batteries and the secondary cells or secondary batteries. Now children, you have to remember the difference between the primary and the secondary cells. Primary cells, you can say, are the, primary cells are the simple electrolytic cell. Simple electrochemical cell. That means in case of a primary cell, we use the energy produced by the electrochemical reaction and it gives out electrical energy. That means reaction takes place, electrical energy is produced in case of a primary cell. Generally, primary cells cannot be recharged. We cannot recharge the primary cell once they are used. After the use, we have to throw the primary cells. They are dead. They are of no use. Whereas secondary cells are those which work as electrochemical as well as electrolytic cell. An example of a secondary cell is your lead storage battery, or you can say the battery which is used in the automobiles, and your inverters and such things use such batteries, in which when the battery is in discharge condition, in that condition the electrochemical reaction takes place, produces electrical energy, and when the battery is finished, then we apply external source of energy, that is the electrical energy, to the cell, and it works as an electrolytic cell and the reaction takes place in the backward direction. So it can work as an electrochemical cell as well as an electrolytic cell. So primary batteries, you can say, cannot be recharged. Once they are used, they are dead. Whereas secondary batteries can be recharged. After use, they can be recharged again by using an external source of electricity, and after that they again work as an electrochemical cell. So, I hope you have understood the difference between the two. Primary is that which cannot be recharged, only electrochemical cell reaction takes place, and secondary are those which can be recharged, that means electrochemical as well as electrolytic. It behaves as both. When discharged, then electrochemical. When charging, then electrolytic cell. Now children, please note down in your fair notebook the notes. The primary cell. A primary cell is that in which the electrode reaction cannot be reversed by an external electric source, and after the use they become dead. They cannot be recharged. Kindly note it down, please. Now, examples of primary cell are the dry cell and mercury cell. Now, what is a dry cell? What is a mercury cell? In your board exam, it may come, you explain the construction, the working and the voltage produced by the dry cell, and similarly it can be asked for mercury cell, and it can also be asked for any of the secondary cells. Now two primary cells will be studying and two secondary cells will be studying. You have to remember, you have to learn by heart the reactions taking place at anode and cathode of these primary and secondary cells. Today we'll finish off with the primary cells. Now two primary cells are there in your syllabus. The first one is your dry cell. What is a dry cell? Dry cell is a cell which is composed, you can say, which is simply a Leclanché cell. It was introduced by Leclanché, so it is also called a Leclanché cell, and it is used in torch, the flashlights, toys of children, the wall clock. They all use the dry cell. Now I hope you have understood, you can recognize what is a dry cell. Now see the diagram for a simple dry cell. The outermost covering of the dry cell is made up of this. This portion is made up of zinc. Outside the zinc can be you can say the cardboard coating, and in case of leak proof cells, there can be a coating of iron sheet, but the outside cylinder is generally a zinc cylinder, which is actually acting as an anode. And inside this dark portion you can see is the cathode. This cathode is a rod of graphite an allotrope of carbon. Outside the graphite rod, the rod is surrounded by manganese dioxide and carbon powder in order to have a difference between the two. And the electrolyte is the paste of ammonium chloride and zinc chloride. Ammonium chloride and zinc chloride are the electrolytes. Zinc cylinder act as anode. Graphite rod act as cathode, and the graphite rod is surrounded by manganese dioxide and carbon powder. Now I think you all have understood the construction of the dry cell. In dry cell, anode is zinc and cathode is graphite. Now children, you have to also remember the reactions which are taking place at anode and cathode of the electrochemicals, this dry cell. Now see, at anode, what happens? You all know at anode generally oxidation takes place. Always oxidation takes place. So what is happening? Zn cylinder converts into Zn2 positive plus 2 electron. That means the zinc cylinder, it dissolves into the electrolyte and gives out 2 electrons. Now these 2 electrons, when the cell is there in the working condition, these 2 electrons travel through the wire which is connected from outside, from anode to cathode. From the external circuit, it travels towards the cathode. Now at cathode, what is happening? NH4 positive, which was present inside the electrolyte, plus MnO2, manganese dioxide, also present in electrolyte. They accept the 2 electron and result in the formation of ammonia and MnOOH. Now this ammonia is not liberated in the form of a gas. Rather, it combines with your electrolyte and the cathode. Now see the overall reaction which is taking place at anode and cathode. The combination of the two is Zn plus 2 NH4 positive, that is ammonium ion, react with 2 ammonium ion, react with zinc and manganese dioxide and result in the formation of Zn2 positive, MnOOH OH plus 2 moles of ammonia. Now children, you have to remember the voltage produced by the dry cell. It can come in the form of multiple choice question, or anything can be asked in the multiple choice question, like what is anode made up of, what is cathode made up of, what is the electrolyte. So all these things you have to remember. And it can also come in the form of a long question to explain the reactions taking place at anode and cathode. Now children, you have to remember that the cell the dry cell, when it is not there in the working condition, then also it can become dead. How it can become dead? It is because the ammonium chloride, which is present as an electrolyte, it is acidic in nature. It corrodes the zinc cylinder, and the zinc cylinder develops holes, due to which a leakage of electrolyte takes place and the cell becomes dead. Now voltage, you have to remember, a simple dry cell produces a voltage of 1.2 to 1.5 volts. Now children, the diagram that I have shown you, the reaction which are taking place at anode and cathode that I have shown you, are of the simple Leclanche cell, the dry cell, which is of zinc and carbon. But there are many other types of dry cells also. There can be silver cell, there can be other types of cells also. Today we have learnt about your simple dry cell, and in your course is only this dry cell. It is clear? Now let us just quickly revise what all things have we learnt about the dry cell. Now dry cell is a type of primary cell. It cannot be recharged, and other primary cell is mercury cell. Now dry cell, where it is used? In clocks, in toys, torch, flashlight, and many other uses are there. It is also called Leclanche cell. Yes. And see the diagram. The anode is made up of zinc cylinder. Cathode is made up of a graphite rod, which is covered by a paste of manganese dioxide and carbon powder. Electrolyte is your ammonium chloride and zinc chloride. The two reactions, anode, cathode, and the overall reaction, you have to learn by heart. The voltage produced is 1.2 to 1.5 volts, and it has an indefinite life because the ammonium chloride is acidic in nature and it can corrode the zinc cylinder. So, I hope it is understood. Now, we are moving to the second important primary cell, that is your mercury cell. See where mercury cell is used. Mercury cell, it is used in the hearing aids, watches, cameras. Mercury cell, it is also called the button cell. It is in the shape of a button. You all must have seen in the watches. A button cell is there. Children, once this question came, name the cell which is used in hearing aids and watches. So, it is mercury cell. You have to remember. Now, mercury cell, it consists of zinc anode and mercury second oxide as cathode. And the electrolyte used here is potassium hydroxide and zinc oxide. Diagram I am not showing to you. You have to remember, it is in the shape of a button, a small round button, and it consists of zinc anode, mercury second oxide as cathode, and the electrolytes used here are potassium hydroxide and zinc oxide. Now see what is the reaction taking place at anode. Now see the zinc amalgam. Zinc amalgam is the paste of zinc with mercury. Zinc amalgam reacts with 2 OH ion from the electrolyte, result in the formation of ZnO plus 2H2O and gives out 2 electrons. These 2 electrons are taken up by the cathode and HgO converts to Hg at cathode and gives out 2 OH negative ion. The overall reaction is the combination of 2, that is Zn plus HgO gives ZnO plus Hg. You have to remember all these reactions. Now see, there is one very important advantage of your mercury cell over all the other cells, that the voltage of the mercury cell which is given out by the mercury cell, it remains constant throughout the life. the voltage of a simple mercury cell is 1.35 volts, around 1.35 volts. Now why it remains constant throughout the life? Because you all can see there's no iron involved in the overall chemical reaction. If no iron is involved, that means the concentration does not changes. As no iron is involved, so the voltage produced is constant. Now children, so we have done two important primary cells. Primary means non-rechargeable cells today. The first one is your dry cell and the second one is your mercury cell. Where is dry cell used? It is used in torch, flashlights, toys, etc. And the mercury cell is used in, that is a small button cell, is used in hearing aids, in watches and many other small things. For lighting up the LED lights also, many a times in small toys it can also be used. Now dry cell is called a Leclanche cell. Mercury cell is called a button cell. Dry cell, the diagram I have already explained, zinc anode, carbon cathode. Whereas in case of mercury cell, the anode is again zinc, but the cathode is mercury second oxide, which is acting as the cathode. Now you have to remember, you have to learn by heart the reactions taking place at anode and cathode of dry cell and mercury cell. These are the reactions of discharge and they cannot be charged. Recharge cannot take place in case of dry cell and mercury cell. Only discharging of the two takes place. Now children, I hope you all are writing all the notes, all the slides which I am showing. You have to note down. They are your notes, and you're solving the numericals also, which I'm giving you along with the this presentation in the form of PDF or in the form of a click. You have to solve all those numericals in your fair notebook. Now children, in the next video, we'll be continuing with the secondary cells. The secondary cells, those can be recharged. So thank you, Sairam.